Thank you for joining us. This is going to be one of our short and sweet webinars. We're just going to go over water quality in solar thermal system. Why does it matter? What are the importances? And I'm certain Bob has seen it all, what water can do, hard water or different type of water can do into the system. And then we'll hear from him and definitely some input from other professionals who are here that I'm certain they have seen what different types of water can do to different components in the system. So very quickly, we're just gonna look at sort of the agenda. We're gonna go over some of the terms, so the problem causes, how to fix those issues, how to go around those, what recommendations are out there, and then some of the preventive maintenance, especially for solar thermal water heating equipment. And then we'll get to any questions that anybody might have, and we'll finish our discussion there. So why water quality matters, I think, more with solar thermal water heating system compared to a normal water heating system. What doesn't even matter more is because you're investing more for a higher efficiency system. You're investing more for a system that's supposed to have a much longer life expectancy than many of the water heaters, the conventional water heaters that you see out there. And this water quality is one of those things that can really impact that life expectancy. So when you're doing that investment and you're calculating your return of investment, you take that life expectancy into account there. Right. And if the water quality damages the equipment to the point that cutting that life expectancy in half, well, all that calculations that you made that justified the purchase of that equipment is now out the window. And the problem, the funny part about the problem is usually the fix is relatively cheap compared to the price of the rest of the equipment that goes in, is relatively inexpensive to prevent that from happening. The maintenances involved are pretty straightforward, pretty easy to perform, and it will save a lot over the life expectancy of the system. So we'll see what happens. So the hardness of the water is basically measured by the minerals. Right. Once you reach a certain level of saturation in the water, then no more basically minerals can be mixed into the water. It will basically sit as sediment at the bottom, and it forms all kinds of blockages and other issues. So more minerals, depends hard water, increase scale welding. So Bob, definitely if you want.
Yeah, the primary minerals for hardness are that are measured calcium and magnesium. There are some technical terms with both of those. It depends on how they're bonded to different carbon and oxygen. But the higher that it's called total dissolved solids, the higher they are, the more potential issues with water heating systems and primarily solar thermal systems in the heat transfer. These minerals kind of bind the metal or heat transfer areas and bind themselves to them on a copper pipe or stainless steel heat exchangers, whether they're direct systems like a direct solar thermal system you'd find in the Pacific Islands or the Caribbean, where there's no separate heat exchanger, but if the water is hard, then it'll coat that. It's kind of puts a layer on the heat exchange, either the solar panel or the tank, and prevents the heat from going where it's supposed to, which is in your water. Dealing with hardness has been around for many years, and the systems that are designed to minimize hardness are readily available and economical and durable.
So then we talked about this right now. What happens with scaling?
Yeah, scaling happens because of the hardness, total dissolved solids, and the temperature. So obviously we're heating water, so the temperature is rising above a certain temperatures. The scaling is increased more than just on a linear scale. It's exponential. It goes up quite a bit as you get into the above usually 140. Scaling starts to occur. So again, we want to keep the water quality, not only hardness, there's other things in water we can talk about, but primarily calcium and magnesium. Some of them in well water, you have to watch out for iron. That can affect copper.
One thing that, you mentioned, going above 140, and how exponentially scaling will go up about 140. And that's one thing to really consider, especially with solar thermal, because we try to, maximize our storage capacity. So if we can, if we have enough energy to store at 160, we definitely want to do that to maximize that footprint that you're occupying with your tank. So in absence of that, what can happen is if the water quality is not checked, basically, then storing water at those higher temperatures can be problematic and leading up to more scaling. One other thing that can happen, which is something to be, definitely related to the quality of water that we're working with, is corrosion. Right. And Bob pointed out to one material in the well water that can lead up to galvanic corrosion.
Yeah,
right,
iron.
With the copper, iron with the copper. That's one great example of if the water quality coming out of well is not monitored and is not treated, the iron in the water, which you can tell if you have a hose and you're like watering your plant, you can see the brown deposit over time, the brown reddish deposit over time on your tile. If you have cement there, you will definitely see it, but same thing will start reacting with the copper in the system and eating away due to galvanic corrosion. Another thing that can happen is oxygen concentration.
Yeah, oxygen is it's an oxidizer, so it likes to bond to things. It likes to rust is, the primary example. So it happens in water systems also. It bonds to metals that we're using, and we want to minimize that.
During our research for this webinar, we came across something interesting with Bob, and that was how the use of salt water softeners could impact their electrolysis corrosion.
Yeah.
Some of them, not all, but we have to keep in mind that in water softeners, the ones that use salt, basically they're replacing those magnesium
and calcium
with sodium. So that will increase the conductivity of the water, which in turn, it could, if there is an electrical current introduced at any point to the system and the water is conductive, then you can see corrosion.
Electricity, what happens is the sodium is more conductive and more reactive to metals. And so it will start to want the sodium ions, they're out there and they want to bond to something. So they'll start attacking metal. Most water heaters, for example, tank water heaters have glass-lined steel. So the glass is not perfect. It's not a perfect glass lining. There's some imperfections, small. So they have what's called an anode, which is a metal, actually magnesium rod in the tank to kind of interact with the sodium, with the water to neutralize to neutralize it, so it's not reactive. Sodium attacks the magnesium quickly, usually in 1 to 3 years. The anode is consumed. That's what they're supposed to do. And then now the sodium says, where else can I be satisfied? And it goes after the tank itself. Yeah. So when you're using a standard water softener that's using sodium salt as the medium to remove calcium and magnesium, you have to monitor and check and change your anode in most standard water heaters. And it's very important with solar because the solar unit's cost, I mean, the cost is higher, and you want them to last, beyond 10 to into the 15 to 25 year range, and you have to. So that's a very important service item to take care of.
We'll definitely get into the details of those maintenance and preventive maintenance services later on in the presentation. Generally speaking, with water hardness, the most recent one that we could find was from 2013, which supported the studies that were done back in the day as well. And we can kind of see the pattern of the hard water and where we see the hardest water, and where we kind of see the soft water, for example, Hawaii, the Pacific Northwest are areas that they see soft water, very good water. The Atlantic Northeast also has, relatively speaking, you can see from the ratio of dissolved minerals in the water, and the quality of water over there is pretty good. Where we see hard water is usually Southern California, New Mexico, Texas, through the southern parts, and then through the areas in the middle. Very understandably are the drier areas. So as the water travels through the land, it's just, as it's drier, it has more minerals in it, and it will just pick up those minerals as it travels above or under the ground. And here is what can happen in an extreme case. This is one of items from Bob's personal museum we borrowed. And
that's a copper pipe that's scaled completely closed. Yeah. This is off a boiler. So again, you have hard water, you have a metal pipe, and you have higher temperatures. And this caused a complete blockage in the water system for the apartment. And they were only getting water through the recirc line very rarely. So it was kind of it's an interesting puzzle to fix. We finally, when we cut it apart, we found, oh my God, I've never seen anything quite like it, but that's what hard water will do. That's another same place.
It's just a progression. You can see on the image above how it starts. And if it's not somehow mitigated, it will lead to that complete blockage. And this is obviously the example of scaling. And then the other side will be corrosion, where you will find pinhole that, and then those can, build up to become ruptures in the system and just like destroy the pipes completely. So what do we do to prevent scaling, Mr. Danielson? Well, what is your solution for that?
Well, scaling occurs, it has to bond to something. So by flushing the tank, basically opening the bottom drain, per manufacturer's manuals, O&M manuals, you just let the water run for a couple minutes out the drain and close it. That keeps any sediment from building up, anything for the more to grow. It's like stalactites and stalagmites in a cave. The less you have, the less growth you'll have. Installing a water softener. Some people install them only on the hot side because as water's heated, the scaling issues are compounded. So you can put a smaller water softener just on the hot side if you want to protect your water heating systems. Draining a few gallons from the tank, that's flushing the system. Checking and cleaning heat exchangers and electric elements. Those are very common in the Pacific areas where there's no gas. Heat exchangers are the primary heat exchanger now is in tankless water heaters. And if you have hard water, they can scale up rather quickly because they're going from 0 to 60 in 3 seconds, so to speak, if we want to put it in Celsius terms. They're going from potable cold water to up to 130, 140 degrees in a matter of less than a few seconds as the water flows through it. So that scaling issue is compounded rather quickly if you have hard water. So standard manual says to flush strong vinegar, mild acids that are available to flush the heat exchangers regularly. Otherwise, your best reason to install a tankless water heater is negated because of the scaling that occurs, and eventually you'll have no hot water. So it's, follow the directions, have regular maintenance on any heater.
Exactly, because for instance, with Bob was talking about the electrical element, with the electrical water heater or a solar with electrical backup, what you eventually can do, if the scaling on it is too bad, you can just replace it altogether. If you happen to have a gas water heater and that plate at the bottom is all scaled up, there is no changing it. Your best bet is to remove it completely and replace it. But if you continuously follow that manufacturer's guideline, that O&M manual, and make sure you flush it on a regular basis, you keep it clean, that will impact the efficiency of your gas water heater. So yes, this is about solar, but again, the main point is keeping the efficiency of your system across the board. Doesn't matter what you're using. By following these rules, whatever water heaters you have, by following the manufacturer's recommendations for maintenance, for preventive maintenance, you just increase the life expectancy of the system. We talked about corrosion, we talked about the glass lining, and we talked about the anode rod. So here we do have a good diagram to kind of get into the detail. As Bob was mentioning, most of the tanks are steel, and they come with a glass lining or other type of lining. That lining is not always perfect, and because of that, to prevent any sort of corrosion from happening from galvanization of different metals touching the steel vessel, or because of the electrolysis process, you have a sacrificial anode. Sacrificial anode is, again, the name is there. It's there to basically be sacrificed to protect the system. And Bob, if you want to get into the details of how it works, how it should be, how you check it, how to change it.
The details are on an electrical scale. So there's a galvanic table for metals, and you have higher numbers and lower numbers. That's their reactivity electrically. So the anode is a softer or less more reactive metal, and it reacts equally with the positive sodium ions. So that's it takes the place, it takes the hit first. I mean, you can look it up. There are simple diagrams that show what's happening. Checking the anode, usually they're at the top of the tank. They're under the cover, have a cap. Some are more easier to take out. You just turn the water off to the tank, drain a little at the bottom, have the correct wrench, take it out, look at it. If the water is soft, it should just be eaten up like a mouse is chewed up, like you see sometimes a piece of vegetable is chewed up. It's chewed up in various places. When about there's a half or more gone, it's time to change it. That's with soft water, it's just completely gone. With hard water, you may have lime that's actually coated the anode. The lime is acting as an insulator, just as it does for the thermal transfer. So you would clean off the anode with a wire brush and replace it. Again, there should be some indication that the anode is dissolving or being dissolved by the water, because that's the protective function of the anode. You want it to be operating. If you pull out an anode and it looks like it has not changed at all, maybe it has a black coating on it, the anode could be defective. That does happen on occasion, and in which case the anode should be changed. Otherwise, the anode's not doing its job. It's something that has been documented. Basically, anodes should be checked within the first year service, and then depending on the water quality, every few years thereafter by qualified technician.
And the same recommendation.
Yeah, on the anodes. Yeah, they're you can actually have tanks that have two anodes if you have water that's you're softening water to a point where it's going to eat up the anode so fast that you need two you need to double team the softening part.
And, well, don't we have just permanent anodes?
They do make electronic anodes,
right,
for large, usually for commercial tanks. Those are available. Look into them. Yeah, that's not what comes with the tank. With our tanks, there are some on high-end boiler tanks available, and they use those because they don't want the anode to dissolve quickly or dissolve and then not catch it, and then their tank is eaten up and develops leaks which are not repairable. And once a vessel is leaking on it in the vessel itself, it's generally not repairable. You have to replace it. So we want to avoid that.
And definitely, there are different components in your system. There is your, for example, the solar thermal system. You have your collector, you have your pump station, your tank. Definitely, there are different components in every system. Always follow the directions of the manufacturer for that components. Do the services accordingly. I'm really looking forward to during to listen to Dale a little about his experience with pumps specifically and the issues that he has seen in his years working with different systems and pumps and different environments. So actually, that's where we are.
Yeah, with soft water, generally, if it's softened correctly, meaning if you're not over softening, most the brass and copper parts are fairly resistant to soft water, so it's not a problem. It's the metal, it's the steel that well, it's glass line, which is pours like a pottery. The glass is fired onto the steel. It's baked on. It's not a liner separate from the tank. So as long as the softener is working properly, you should be fine, and the anodes change. The other side of that, just as an aside, is in some like islands, the water could be wells, and it may be very contaminated. So some of these islands have RO systems which take out all the minerals. So you have very low TDS. The opposite of that is the water has no ions, and water becomes kind of corrosive, and so it'll attack primarily metals, and copper's susceptible to this. So you don't necessarily want pure distilled water or deionized water as your in copper pipes.
That goes for rain catchments.
Rain catchments is possible. You can always have cartridges that add calcium, dope it so that it it's what it is neutralizing the water, so it's not as aggressive. The result, what is you see pitting in the copper, you see, and that occurs not only if the water is highly pure, in which case they usually use stainless steel or plastic with that kind of water if you're using it in any application. Or the other pitting issue could come from sanitation that the municipality uses. If they over-chlorinate, if they're using chloramines, that can affect direct copper solar collectors if the water is in direct contact with the absorber. Rain catchment in Hawaii, sometimes you get acids from the volcanoes. So, acid rain kind of comes down, and they've seen metal roofs in Hawaii corrode and pit because of the rain. And so that if they're doing catchment, they have to treat it. So there are relatively straightforward ways of testing your water. If you're on a well or a catchment or even your municipal water, you can have it tested to make sure that it's within standard parameters that usually the water departments have. Again, there's also a point of use water conditioners out there. A lot of them more and more popular to deal with a lot of the chemicals and items that are coming into the water. So those are something to look into.
Definitely. And then there is we proactively some of our hot water stations are now coming already equipped with water filters and water softeners. Just in areas that we know there will be more in demand just because of the quality of water to begin with. So we are also trying our best staying ahead of this game and incorporate this existing technologies into our designs, into our solutions as much as possible. So at this point, I want to open for any questions that anybody might have, any experiences they had either with scaling, corrosion in different systems, different equipment. Please do share.
Yeah, again, we have water is usually hard, which means there's a lot of total dissolved solids. There's mechanisms and equipment to deal with that. Then there's super soft water, really not generally a problem unless it's very, very soft or distilled. You usually have soft water, like Amir mentioned, in the Pacific Northwest, Northeast, where there's a lot of rain. There's not a lot of water running through rock that picks up the hard chemicals. That's why the midsection of the country, you have the Colorado River, and you don't have, you have a lot of wells, which pull it out of the ground. That's where you get a lot of hardness. And there's effective ways to, if you're in that situation, to deal with the water and get it to a point where it's ideal for all your plumbing in the house, including solar systems.
So I have a comment from Seth over at Low Energy in Colorado. Hey Seth, thanks for joining us. Thank you for your comment. And he's saying they use an anode. They use a system that incorporates an anode into a closed heating system. So I bet if you have a closed loop heating system, you have an anode in there.
You can. A lot of closed systems are not, especially well, now there's still a lot of them. Like boiler systems, they're closed, but they have makeup water, and if the makeup water is not treated, as the water in a closed system is disappears for whatever reason, makeup water comes in, so that the dissolved solids are increased by kind of like evaporation. If you had water in your cup and you kept filling it, and all of a sudden you see the scale on the side of the cup, that's the dissolved solids you're seeing that are staying. They don't go up into the air, they stay with it. So you have to treat with those kind of systems. You have to treat the water, the makeup water that comes in. That hasn't been done. There was a study just done at a boiler system in Kansas at a school that they had problems with, and they found out there's other things going on, but the water was one of the culprits. They had scaling. Anodes do in a completely closed system. Yes, an anode will or buffers in the fluid can protect and scavenge. What they do is they scavenge the anodes, the breakdown of some of the chemicals like antifreezes that are overheated. The breakdown is acid, usually a mild acid, and so combination of buffers in the closed system and an anode can protect that. Yeah, that's not a bad option to have anodes in systems like that.
And Seth is also mentioning that their customer use filling units to demineralize the site water.
Right, exactly.
So
Pre-treatment. Yeah, the point of use filling. If you have a system that has to be refilled every once in a while, then you have it treated from the water your supply. You pre-treat it before it goes into your actual operation, into your hydronic heating system or water system or whatever. Wherever you're using a fluid, you want the fluid to be neutral to all, or as many of the components you have as possible.
Right. I mean, as you said, just mentioned, it keeps the water chemistry in check.
Yeah, it's a balance. I don't know, the buffer you add. The buffer's there in the water, you can't see it, it's dissolved, and let's say you add acid, well then the pH of the water doesn't go low until the buffer's all gone. So it's kind of like an anode.
And then the anode is there, and then you do the filling. So you just do as much as you can to prevent any damages to the system, because again, the capital investment usually in a closed loop system it's pretty, you want to protect that system. It makes sense. It's just the same reason why you buy that surge protector for your expensive TV.
That's exactly right.
Because the cost of replacing the unit is so high that it will justify going that extra step to treat the water, to neutralize anything that will come in that could damage the water chemistry.
Right. And you can treat only the hot water side. That allows you to put in a smaller treatment system. You don't necessarily need to treat your entire house. I mean, some people are doing that. Usually, if they want to do it, that's fine. They're being sold, quite a few of them. But you only need to treat what's being used in the heating system. So that may be substantially less. You're not washing down the garage with it, or you're flushing the toilet, or just letting the cold water run. You may not need to treat the whole house. Again, it's dependent on the supply coming in from either a well or the municipality.
So we talked about how soft water increases your conductivity to some extent, right?
It's like soft water is similar to the ocean. Right. Salt. There's sodium. It's the sodium in the water that is active. It's the active ion when it's in water, and it doesn't like to be alone. It wants to bond to something. So it's kind of like oxygen. It bonds to iron, and you see rust. Sodium attacks steel in the same way. It's like salt water does and destroys it. So we want the anodism for the primary part of that tank. The anode is the most important item to help prevent corrosion, and it's the most important item to check and maintain.
Right. Well, I think that's our presentation, and I'm just gonna wait to see if we get any more comments or questions from any of our lovely audiences.
I mean, just as a point aside, with tankless water heaters, they came in and saved energy and everything, but then the kind of the flip side of it is they have to be serviced so that the heat exchangers are cleaned. And sometimes the services are yearly, and sometimes every 6 months. So service isn't something that you should shy away from. Building something like that into your contracts, or annual service for a system, maybe as part of your warranty. You might have your own warranty, and but you have to have it serviced. Like a car, you take it in. If you don't have it serviced, the warranty is, it's no good anymore. It's void. So the same thing with solar. People are spending an awful lot of money for these systems, and have it checked. There's ways to streamline the anode checks, or so that they don't take as long as they may involve some changes with the anode, but it can be done over time. If you have long-term customers, this can be made to be a part of an hour or hour and a half service call, and the technician isn't struggling. Anodes are initially put into a tank, and the manufacturers don't want you to take them out. They don't expect you to take them out. You have to read the use and care manual. It does talk about it, but they make it difficult. So anodes are available for replacement once the anode is consumed, the original one, that are much easier to take out, much easier to service. It makes it faster. Instead of a 30-minute project to get the anode out, it's 5 minutes. So there are ways to, once you're doing the service, you can minimize the time for you, and then it saves the customer a little bit too. You can focus a little more on the other parts of the system if they need it.
Well, definitely. Thank you so much for sharing your experience. Thank you, Seth, for your comments and for your input, and thank you everybody else for taking the time and joining us for another SunEarth webinar. This one was on a shorter side, but again, it was, I think, one of the more important ones that we did, because it's a very simple subject. It's relatively inexpensive to mitigate and prevent from happening, but it can have huge impact on the life expectancy of the system, the efficiency of the system, and the overall operation of the system. If anybody would like to continue this conversation, if you guys have any more questions for us, if there is anything else that comes up later on that you didn't think about it right now but want to know more about it later, please feel free to get in touch with either me or Bob Danielson. That's our contact information. We'll be more than glad to talk. And thank you all again for joining us today.
Thank you. Yeah.